Okay, now for part 2 of 2.2 linear inequalities, we are looking at the bottom of page 27 in your workbook, properties of inequalities. There are two properties used with inequalities. The addition property, which just is the same as it is for equalities. We can just add something or subtract to both sides as long as we balance. We're good there. Multiplication property holds the same too. We can multiply or divide, and as long as we do it to both sides, it works for us. However, if C is less than 0, if it's a negative number, then the inequality reverses. So if you multiply or divide by a negative, then reverse the inequality symbol. So keep in mind when you're doing your work, you might want to keep a note card or a note sheet or something of all the key things. So when you're taking a quiz or test, something that's timed, you have all the quick lookups. Like, just use it as a fail-safe. Don't rely on like using your notes, but have things organized so you can just remember it, because sometimes people forget that. So if it were me, I would put that on a note card. I do want to talk about the concept that if we have, for example, we say 2 is less than 5. I probably agree with that. That's a true statement. But what if I were to multiply or divide? Usually we're doing division here. So if I divided both sides by -1, for instance, or I changed each of them to their opposite sides, then I would end up with -2 and negative on the left and -5 on the right. But now what happens if I just carry that less than down? That's not going to be a true statement, right? -2 is not less than -5. So this is why we have to reverse that inequality. Okay, so we can keep it true. -2 is greater than -5 is true. Likewise, if I have something over here, I'll put it off to the right. If my equation when I solve, or my inequality when I solve it, I end up with 2 less than x, we want to switch it around because we read left to right. So we want to have our variable to the left. It doesn't matter what's happening when we're solving, but at the end we want to have a nice format. So we would have to again reverse the inequality because the open part's to the x, so we want to keep that the same way. So x is greater than 2 is the same as saying 2 is less than x. So be careful with that, okay? All right, now moving on to page 28, 2.12, solve the inequality. Graph the solution and write the solution in interval notation. So now we're combining a bunch of skills. So for part A, we're just going to add 5 to both sides. So it's the same way we would solve it if there were an equal sign. So we would add 5. And then we end up with 2x less than 8. And we divide both sides by 2. And we get x is less than or equal to 4. So that's writing it as an inequality. And later you'll see that as set notation. We would just put some braces around that. And then we will graph it. So just a quick little graph. We don't have to put all the numbers in. Just make sure you put the one that we're talking about. And then we have a bracket, and the arrow should go left. It's everything less than 4, but including 4. And then lastly, our interval notation will be -infinity to 4 with a bracket. Make that match in color. So those are the three forms of an answer. Sometimes a lot of times you are asked to do all three, like on a paper quiz or homework, because I just have one, so I just want to put it in there. In your homework, you might have difference of those, just saying one or the other. Okay. So B, I want you to try that one on your own and see how that goes. Now remember our rule that when you have to multiply or divide, that's a hint for you, by a negative, then you must reverse the inequality. So that could possibly happen depending on which route you go for solving. So this one I'm going to label as CW for classwork, or sometimes I call them try it on your own, virtual classwork. So go ahead and do that now. Okay, so I've mostly solved this one out. We're going to first subtract 3 from both sides. Then I get x less than 3x minus 10. Then subtract 3x from both sides. And then I get negative 2x less than negative 10. So here's where I'm going to divide both sides by negative 2. And then I want to be real careful here that x is greater than, that's when I switch the inequality, positive 5. That causes the sign to change on the other, on the constant number there. So that would be my answer in just inequality notation. And then here's my answer in graph. And my answer in interval notation. Okay, so be careful about that. If you ended up not having the right direction for things, then go back and review this, concept in the rule again. Okay, these two are pretty tricky. I will do them out in the video, but I think it might be a good idea if you pause the video, try them on your own, and then I'll do them and you can kind of check at points just to see how you line up and if you get stuck. But I will do it as a video and talk it through. But go ahead and try it. It might take you a little bit. Okay, so for C, we have negative 2 times quantity 1 minus x plus 2x greater than 7x plus 4. So first thing we want to do is distribute. So this is really good practice for solving equations because it's the same as solving inequalities and using those skills. So negative 2 plus x, or 2x plus 2x greater than 7x plus 4. So that's my first line there. Then I'm going to combine like terms. So I get negative 2 plus 4x. So I'm dealing with just one side of the inequality. So I'm just going to combine. I'm not balancing anything off yet. Greater than 7x plus 4. Now I can start my solving process by balancing off the sides. I am going to go this route. I'm going to subtract 4x from both sides. That's what I'll choose. Doesn't really matter which direction you go first. You can just, as long as you get it as a variable term equal or greater than a number, and then you do the division process. So I'm going to do that first here, and that will end up getting rid of that. Then in the same line, because I'm going to start having you guys streamline a bit, I need to get this 4 off the right hand side. So I'm going to subtract 4 there and 4 on the left. So now I need to crunch those numbers. So I get negative 6 greater than 3x. If you still want to do that in 2 steps, the line above, you can. That's totally fine. Divide by 3 on both sides. It's not a negative, even though the negative 6 has a negative symbol. We're not going to reverse the inequality at this point here. So we are left with -2 greater than x. So there I did not reverse anything because I did not divide by a negative. But now in my final answer, I want my x on the left-hand side. So now I need to kind of switch things around and make it say x is less than -2. And then you would write your graphing. Would look like this. It would be -2 down to negative infinity. Maybe do that in a different color here. Whoops. I'll do that in a different color for you. And then we also have, we want to write it in interval notation. So that's going to be negative infinity to 2, and neither of those is included. So we have it as curved parentheses. So I hope that went okay. I know if this is new for you, it could be a little tricky. So email me or message me in Canvas if you have questions on it. Or we could talk about it in the Zoom time as well, or just in by appointment Zoom time. Okay, for letter D, 4 plus 2x all divided by 3 greater than or equal to quantity 3x plus 1 in the numerator all divided by 2. So first thing I want you to start getting in the habit of is thinking about numerators as being, or denominators as being grouping symbols. So we're going to add those around, add some parentheses around. Just so when we start solving this, we don't forget to distribute. Okay, so if I want to clear the denominator, I have a couple fractions, so I could multiply both sides by the lowest common denominator, which would be 6. And then I can reduce on the diagonal. So I have 3 into 3 would be 1. 3 into 6 leaves me with 2. 2 into 2 is 1. 2 into 6 is 3. And then I have, I'm just going to rewrite that to clean it up a little bit there. So I have 2 times 4 plus 2x in the parentheses greater than or equal to 3 times 3x plus 1 in parentheses. Now I can go ahead and distribute, and I get 8 plus 4x greater than or equal to 9x plus 3. Okay, so make sure yours matched up to that. Now I would just follow the same process as I've done before, now that I've dealt with the fractions. So I'm going to, this time, let's see, I'll subtract 9x from both sides. So it gets rid of that. Now I need to subtract 8 from both sides. Gets rid of that 8. So now I'm left with 4x minus 9x gives me a minus 5x greater than or equal to a negative 5. And at this point, I'm going to divide both sides by negative 5 to get that x by itself isolated. And when I do that, don't forget, you want to reverse your inequality. So you may even just do that first as soon as you know you're going to need to divide by a negative. It's easy to forget. It's not maybe that you don't know you're supposed to do it, but you just forget to do it. You're multitasking. So maybe do it before you even write the numbers. So we end up with x is less than or equal to 1. And my graph will be here. Here's 1. And then I'm going to include the 1 and go to the left for my arrow. And then I would write it as negative infinity up to and including 1. And I'm done. So that's it for part 2. I'm going to make a separate video for part 3. We'll look at tripartite inequalities, which are trickier. Sometimes I call them like sandwich inequalities. So this one's getting a little bit long, so we'll stop there. So have a great day, but don't forget to catch that last part for 2.2. It'll be page 29 of your workbook.